So for this problem, I'm going to label only children as population 1 and then children with siblings as population 2. It really doesn't matter which one you label which, you just have to stay consistent. I'm going to think now about my hypothesis. So the null hypothesis is nothing is going on here. And what are we asking as the researcher? We're asking that, is there evidence that the mean score of only children is lower than the mean score of children with siblings? So let's do the alternative first. So we're asking, is mu1 less than mu2, which means that if nothing is going on, then actually mu1 is greater than or equal to mu2. So that's the setup there. If nothing is happening, typical only children, average only children score is actually as high or higher than the score of kids with siblings. Once you've got your hypothesis set up, then you're in position to compute the statistic t. So I do need to write down, or no, I've already got them, the averages here. So I've got the average for only children is 1.95. And then I subtract the sample average for children with siblings is 2.06. I'm going to divide by the square root of the first population, 1.04 standard deviation, square that, divide by the sample size of 233. You don't square the sample size. Then I take the second population standard deviation, so 1.111, square that, divide by that sample size. Those are very different sample sizes. When you run this, you should get t is negative 1.4937. Then you hop over to your app. You're going to use your degrees of freedom. Nu is going to be the smaller of the two sample sizes minus 1, so 232. So you want the probability that the t-distribution with 232 degrees of freedom is less than, mirroring this less than your test statistic, negative 1.4937. Plug that into the app, and you should get out about 0.6831, which is very large. And so we would conclude here that the data is not statistically significant. And it does not give evidence that mu1 is actually less than mu2. Or if you want to use the classical language, you would say here that we fail to reject the null hypothesis. And there you have it.